But there seems to be somewhat of a common consensus in the data. These are just selected publications. I could put a couple hundred publications up here. Around a meter by the year 2100 seems to be a very consistent middle point, maybe even on the low end, of what we might expect by the year 2100. Think of a meter in your community, and what does that look like? If you're near the coast, it doesn't look pretty, I can tell you that. So again, this is an example of the type of thing you'll see in the IPCC report. And don't worry about all the data here. This is, has to do with sea level rise projections. The take home here with this slide is the left half of the chart are observations. And you can see as you get back into the 1800s, there's a lot of uncertainty around the data. That error bar is pretty large. And then as you get closer to present day, right here in the middle of the chart, our uncertainty is essentially zero because we're observing it. And then as you go into the future, the uncertainty gets even larger. And the closer to the year 2100 you get, the larger the uncertainty is. But know that there's a range of projections. There's high, medium, and low. It's actually what the Army Corps is using right now when they design projects. The US Army Corps of Engineers, they're required to consider sea level rise in their engineering designs, and they get to choose a high, medium, or low aspect to their projections. Okay, so this is a fun slide that people tend to get really fascinated with. This is satellite data over the course of the last 15 years that is compiled. So it's all 15 years worth of data. The hot colors indicate accelerated rates of sea level rise. On the order, if it's dark red, it's 10 to 12 millimeters per year. The cooler colors and the blue areas, which aren't many, are indicating decreasing sea level rise. And that kind of neutral zone, the light green to even kind of teal color, is basically neutral. But you'll notice the first thing that jumps out at you is that it's not, sea level's not uniform everywhere in the world. And they say that for ice melting in Greenland, if it was to catastrophically melt overnight somehow, it would take 30 years for that water to fluctuate, to get all the way into the Pacific Ocean. So it doesn't happen instantaneously. In addition to that, the satellite data is suggesting there's other phenomena going on that affect regional sea level rise. For example, in the Western Pacific above Australia, you see that big patch of red. That is an accelerated rate of sea level rise. When you hear about sea level rise in the South Pacific or in the Western Pacific, Tuvalu, Marshall Islands, Micronesia, not only are they very low atolls with hardly any elevation, but they are actually seeing sea level rise on the order of 3 or 4 times higher than what we're seeing here in Hawaii. So it's very real to these communities. This is not necessarily due to climate change directly. That piling of water in the Western Pacific is warm water thought to be driven by an accelerated trade wind regime coming from the eastern part of the Pacific Ocean to the western part. It's pushing water and piling it up. Turns out when El Nino kicks in, those trade winds die off and that bulge of warm water relaxes and moves east. So sea level in the Western Pacific drops up to a meter. Amazing, up to a meter. Right now Guam, their tide gauge in Guam is a foot lower than it should be because we're in a minor El Nino. So just know that it's not uniform everywhere in the world. So notice here in Hawaii that we have kind of a sweet spot. We're in a neutral zone, about 3 millimeters a year. We're in actually pretty good shape if we can just keep it there. But also notice that we have red on either side of us, north and south of us. And if that was to change, we're going to see more of the same problems that we see on the coast. Here's our Honolulu tide gauge. We're averaging on each island is a little different in our regional sea level because of the tectonics and the way the islands are going up and down. But Honolulu is about half of the global average at 1.5 millimeters a year. Here's the average over the last 100 years. There's that linear rate in red. But are we really interested in averages? No. We want to know what the extremes are. Those highest tides of the year, that's where we see all our action. That's where we see the damage. And that's where all that focus is now, is what do those highest tides of the year look like in the future? Here's what they look like now. You saw this image earlier. This is Waikiki Beach a couple summers ago. Not a surf event. This was purely tide. Barely any waves at all. This was the North Shore this last winter. I can't say this is due to sea level rise. I like to show these slides as they're very dramatic of erosion, but they indicate what our future may look like with increased erosion. We're going to see more of these type of erosion events in the Hawaiian Islands. And as I'm wrapping up here, I just wanted to point to there is a really nice new sea level rise viewer. It's a national viewer produced by NOAA. You can Google NOAA sea level rise viewer, and I'll have to caution you, it's addictive. It's like Google Earth, right? You zoom into your community, wherever you want, anywhere in the US, and you can play with the scroll bar on the upper left-hand side, and you can flood areas up to 6 feet. It's amazing. Try it for Kailua. It's pretty eye-opening. I think I have an image here of what Waikiki looks like under a 6-foot sea level rise scenario. So it's a Google map, and you can play around with the data and see what different increments of sea level rise look like in your community. A very powerful screening tool for planners and decision makers to start to think strategically about what are we going to prioritize in the future. There's this level of confidence around this data, and with that, I don't know if I made up any time, but I want to thank you for your time.
Thank you so much, Dolan. So we've heard now about climate change and the methane release, something about sea level rise, and now Dr. Camilo Mora is going to talk to us about biodiversity impacts and also impacts to food production.
Well, thank you very much. Well, as Stuart said, the computer there. I have to, of course, thank you very much for taking the time to hear about this presentation, and I also have to tell you that I find pretty challenging to do these presentations in such a brief amount of time. The reason being that the work that I'm about to show you took 20 years to generate. So you can imagine how challenging it is to summarize 20 years of work in a 50-minute presentation. So let me get to it. The work that my lab and I are doing are about understanding the vulnerability of people and species to climate change. The alternative title of my presentation is "We Are Screwing It." There is just no other way that you can summarize what we are doing to our planet than this title. When you look at the climate, it turns out that the climate is a very important driver of social and ecological systems. You and I are living here just because the temperature